With page 5, number 12, the graph of the piecewise linear function f is shown above. What is the value of the integral from -1 to 9 of 3f of x plus 2 dx? Okay, so if we break this down, we have the integral from -1 to 9, the 3 out front, f of x dx, plus the integral from -1 to 9 of 2 dx. Okay, so we need to calculate the integral from 1 to 9 of f of x dx, which means we're going to start here, we're going to go all the way here, and we have to find the area. So we have two regions here, one that's below the curve, and then one that's above the curve. I'm sorry, the x-axis. I said the curve, I meant the x-axis in both cases. All right, so we can actually count some, you can do the trapezoid, but if you want, but we have 1, 2, 3 blocks, and then a half a block. So this is going to be -3.5. Over here we have a triangle, so that's 1/2 the base, which is 6, times the height, which is 2. That's equal to 6. So above the x-axis is 6, below the x-axis is -3.5, so 6 minus 3.5 gives us 2.5. So we have 3 times 2.5 plus, and then just like in the previous problem, this will be 2 times 9 minus -1. So we have 7.5 plus 2 times 10, that's 20, so we want 27.5. For number 13, which of the following integral expressions is equal to this limit of a Riemann sum right here? All right, so when we're looking at these, we can start with the fact that delta x is equal to this expression right here, 1 over n, which we also know is b minus a over n. All right, so b minus a must be equal to 1. So the difference between our low bound and our upper bound in our integral has to be just 1 unit. A is down here, b is up there, and the difference can only be 1 unit. Well, that kind of gives away our answer, because if we look at our 4 options, here's a difference of 1, here's a difference of 3, here's a difference of 3, and here's a difference of 3. So the answer must be A. But let's go a little bit further, just so that you make sure that everybody understands what's going on here. Because some of you may say, well, I see the 1 plus the k term, so doesn't that make A equal to that 1 right there? And the answer actually is no, it's not. So I'm going to cross that out. And again, the reason why is that because we know that A is in parentheses with the k term, and there's nothing in parentheses with k. So then we see 3k over n and 1 over n. So why is this our delta x here? What's happening? Well, this we have to think of actually as 3 times k times 1 over n, like that. And that's where our 3x is coming from. This 1 is definitely the numerator of our delta x. So we know that the difference between a and b is just going to be 1 unit. But that's leading up to why A is our answer.